In this module, we will cover the mediator pattern. Its intent is to define an object, the mediator, that encapsulates how a set of objects interact. I'm Kevin, and I'll guide you through it. We will start by describing the pattern using a real-life example. The archetypical example for a mediator is a chat room, a common use case which everyone can easily understand, and chances are you'll have to implement something along these lines during your career. We will map that to the design pattern structure, and we will implement it in a demo. We'll continue with learning about use cases for this pattern, consequences and related patterns. The mediator pattern is a behavioral pattern from the Gang of 4 library of design patterns. The intent of the mediator pattern is to define an object, which is the mediator, that encapsulates how a set of objects interact. It does that by forcing objects to communicate via that mediator. By doing so, it promotes loose coupling by keeping objects from referring to each other explicitly, and it also lets you vary their interaction independently. Let's elaborate on that a bit. On the left, you see a set of objects that need to interact with each other. To be able to do that, these objects need to hold references to each other. If we're talking about just a few objects, that is still okay. But imagine that these are not a few objects, but tens, hundreds, or thousands of objects. Holding on to all of these references and managing them and keeping communication in sync becomes a real issue really fast. Enter the mediator pattern. What this pattern does is provide a central object, which is the mediator. It maintains references of objects that want to communicate with each other, and it handles communication between them. As you can see, all of a sudden this has become more manageable. Let's map this to a real-life example. Imagine we're writing software for a team of people working at a bank. Amongst them, account managers that sell banking products and lawyers that check these products for compliance. A part of the software we need to write is a chat app, which needs to be custom built due to high security and confidentiality requirements. We are building that app. We could now create team member objects that hold references to all other team member objects that need to communicate with each other, but that is exactly what we don't want to do. Instead, we will use the mediator pattern. We start with one central object, the chat room. This is abstract. It defines the interface for communicating with team members. Remember, as usual with these patterns, and as detailed in the introduction module, these patterns want to encourage working on interfaces and not on implementations. Technically, that means either an abstract class or an interface. Let's go for that last one this time, and we name it iChatRoom. A concrete implementation of this would then be named TeamChatRoom. And then we have a team member. Again, an abstract class which holds a reference to the abstract chatroom interface. It needs this to be able to communicate with it. So, instead of communicating directly with other team members, it communicates with the chatroom. Our lawyers and account managers are then concrete implementations of the team member abstract base class. These are the objects that effectively receive and send messages through the chatroom. This team chat room thus holds the actual references to the team members. Let's map this to the mediator pattern structure. The abstract chatroom class, that's our mediator. This defines an interface for communicating with colleague objects. Such a colleague maps to our team member abstract class, whereas account manager and lawyer are concrete colleague classes. They know their mediator and they communicate with it when they would have otherwise communicated with another colleague. Lastly, we have the concrete mediator, our team chat room. This derives from mediator. It knows and maintains its colleagues, and it implements cooperative behavior by coordinating colleague objects. It thus routes messages between them. And with that, it's demo time. We'll start with implementing our bank team chat example. After that, we will extend it by supporting communication between specific objects only. We'll start this demo with the mediator object itself, the chat room, an abstract base class of which will require a concrete implementation later on. The functionality required is sending a message, so we add an abstract method for that. The parameters we want to accept here really depend on your use case. What's accepted here is what the mediator has access to and can thus communicate to the team members or use for additional logic. A from parameter and a message parameter seem like a good idea for our demo. We currently don't support sending something to a specific member or set of members. The other type of functionality we need is registering users for our chat room, so we need a register method. As a parameter, it accepts a team member that needs to be registered. We don't have that class yet. So let's add it. We won't add implementation yet, this is just to make sure that this resolves. As we learned on the slides, the team member class 2 is an abstract class. We've used an abstract base class here, but as we didn't provide default implementations, you could technically implement this as an interface as well. So why not do that? So we'll switch this around a bit. We create an interface for our mediator and we get rid of the abstract class. When you don't have default implementations, there really is no need to work with an abstract class. Let's continue with our abstract team member class. That's the colleague from the pattern structure. It needs to hold a reference to our mediator, as it's through this mediator that it communicates with other team members. In principle, this mediator doesn't need to be accessible from outside of this class. We can have this class send the message through the mediator and have subclasses simply use the base method we define. We also add a name property to hold the member's name. To convey that we don't want these to be null, we add a constructor which accepts both the name and the iChatroom implementing instance. But there's a potential issue with this. It's the iChatroom implementation that sets the mediator for each team member when team members are registered on it. So at that time, the team members are already constructed. So we need to change this a bit. We make iChatroom nullable, and we add an internal method to set the chatroom instance to avoid this being possible from outside of our assembly. We now no longer accept a chatroom via our constructor. There we go. And then we needed to implement the method to send messages. So we add a send method, and in it we accept a message and use the mediator to send it. The from parameter is the name of the team member. Team members don't only send messages, they also need to be able to receive them. So that's the last method we want to add here. A concrete mediator will call this method on each team member it manages to communicate messages to them. For our demo, we will write out the message we receive to the console output window. What we also want to do is mark this method as virtual. By doing so, we allow concrete implementations to override it and provide their own specific implementation if needed. So we're working on an abstract class here, and this time it does contain implementation details. We cannot switch this out for an interface. Then let's add a concrete implementation of this team member abstract base class, the lawyer. We call into the base constructor and we override the receive method. We marked it as virtual, so we are allowed to do that. Like that, we can write out which concrete class received the message. Next to that, we also call into base.receive to write out the message itself. And then we do something likewise for the account manager class. And with that, we've got our two team members. Now we can continue with the concrete mediator implementation. That's our team chat room, which implements the iChatroom interface. So we choose to implement it. And that means we need to provide implementations for two methods, register and send. Team members are registered via the register method. Seeing our team chat room needs to know which members to send messages to, it needs to store them. There's multiple ways of doing that. Collections, lists, whichever construction you want to use. As I happen to know that I'm going to want to search for people by name in the next demo, I'm going to use a dictionary. In the register method, we then link the mediator to the team member by calling into setChatRoom. When we call into it, we pass through the mediator itself, this. setChatRoom expects an iChatRoom implementing object, which in this case is our team chatroom instance. After that, we add it to the dictionary. This, by the way, does assume that name must be unique as we're using it as key. If that's not something you desire, use another key or another collection construct. And then there's the send method. Sending a message through the mediator assumes that all members must receive it in this scenario. So we run through all of them and call receive on them. And that's it as far as the pattern implementation is concerned. Let's write some code so we can try this out. First things first, we new up our team chat room. For that, we need to import the mediator namespace. Then let's new up a few team members so they can chat with each other. We'll add 2 lawyers, Sven and Kenneth, and 3 account managers, Anne, John, and Kylie. These are the 5 team members that will chat with each other, so we need to register them on our chat room. For that, we call into register on our team chat room instance for each of them. And then let's see what happens when we send a message. Let's say that Anne is going to send a message because she needs a compliance check on a file. Sven sees the message and says he's on it. Let's add a read key statement. And let's give this a try. And there we go. We see that our 5 team members all got Anne's message. And after that, we see that the message that Sven sent was also delivered to these 5 team members. Our mediator works as expected. But maybe not everyone should receive every message all the time. Let's see what we can do to improve our example in the next demo.